Hi, my name is Doricko, and I'm the co-chair of marketing for Caribbean and Latin America for the MEF. And today I'd like to talk to you about MEF 22.1, the Mobile Backhaul Implementation Agreement for 4G and LTE technologies. Today we'll cover packet synchronization over a carrier Ethernet network, and also we'll cover carrier Ethernet 2.0 multiple classes of service for mobile backhaul. So 22.1 comprises of a number of standards from different organizations in the industry, and the two I'll cover, like I mentioned, is the synchronization first, and concepts of synchronization for carrier Ethernet. First of all, there's an EVC, an Ethernet virtual connection, where you can embed the synchronization traffic going out to the mobile radios inside the EVC within the payload of the circuit. The second way is actually separate a different class of service in that EVC, so you can give a higher, almost call it the fast lane or better channel to deliver synchronization. If you look at carrier Ethernet and some of the LTE advanced standards, like Release 10 coming out of the 3GPP, there's going to be a number of synchronization enhancements required, things like time of day and phase synchronization, in addition to today's commonly distributed frequency sync. So these technologies will require the carrier Ethernet backhaul network to actually deliver very low latency, guaranteed throughput for this synchronization traffic. Some of the most common protocols we'll see is border clocks using 1588 version 2 protocols for time of day and phase sync. And for frequency sync, a common technology will be synchronous Ethernet. The MEF 22.1 reference guidelines, so you can look at what the target performance objectives are for delay, jitter, which is delay in packet arrival, and then also things like the frame loss and what LTE backhaul would require when you're doing these different performance monitoring capabilities built into 2.0. And going into multiple levels of QoS, this is defined in MEF 23.0. Basically, what the MEF is proposing here, today the mobile backhaul networks are all built around a single committed information rate or a single class of service. So basically, if the maximum burst rate to a cell tower would be 100 megabits per second, the mobile operator would purchase 100 meg of committed information rate. The challenge with having a single QoS level is basically that time-sensitive synchronization and control traffic on the radio access network would have to wait in line several time slices when there's actually a jumbo frame, like a 2,000 byte frame with web or data traffic. The delay-sensitive synchronization traffic would have to wait, and it would actually wait until that large jumbo frame gets transmitted. If you look on the bottom portion of the diagram here in the green circle, you can see how there's a high priority lane or a high class of service that's dedicated strictly for radio control traffic and synchronization. And that high priority lane allows synchronization and critical traffic to get out to the radios and back on this dedicated, call it like a carpool lane. Notice how the bursty large jumbo frames that are web traffic out to the towers would basically be in a low priority lane, so they wouldn't slow down the delay sensitive synchronization traffic. Some of the target SLAs around those performance tiers, you can have as many as 4 classes of service defined by the MEF. And if you had 4, you'd have a very high level, which is strictly for sync traffic. You'd have a high level, which is for conversational traffic, signaling, and network management and control. And then your medium and your low class levels would be for streaming media and interactive web traffic. If you went to a 2 QoS model, your sync, conversational, and control traffic would all be put in the medium tier, and then your low performance tier would be the data traffic or user traffic. And taking a quick snapshot of the differences in what was enhanced on MEF 22.1 versus 22. If you look here on the chart, in MEF 22 back 3 years ago in 2009, it included the user network interface to the radio access network, and it included the EVC types, which would be E-line, ELAN, and then some of the OEM. In other words, how do you monitor the service and delivery on the carrier Ethernet network? And it included GSM, CDMA 2000, WiMAX technologies. If you look to the right, MEF 22.1, which we completed in the past 6 months, actually adds a number of service OEM fault management and performance management capabilities on the radio access network. And it adds a number of different synchronization reference models for 1588 version 2, as well as SyncE. And it also dictates some of the performance and resiliency that you can build in using either multiple EVC paths out to each eNode B, or also using ring technologies like G.8032 to give fiber route diversity out to the towers. And then the other big addition in 22.1 was actually adding performance objectives and what the network should perform to when you're doing 4G and LTE backhaul. So in summary, please visit metroethernetforum.org website and look for the packet synchronization white paper for mobile backhaul networks. And then there's a second white paper we strongly recommend, which goes into optimizing mobile backhaul with efficient implementation of the multi-classes of service. Thank you very much, and this is Eric Doricko signing out.